Hello, welcome to Physics Time. This video gives you a detailed solutions to Kerala State Higher Secondary Examination conducted on March 2025. So, students, let's begin with the section of 1-mark questions. Here is the first question. The electrostatic force per unit charge is known as. Options are A. Electric current, B. Electric potential, C. Electric field. Answer is option C. Electric field. Detailed solution. The quantity described, electrostatic force per unit charge, is the definition of the electric field. The relationship is expressed by the formula A vector is equal to F vector divided by Q, where A vector is the electric field vector. F vector is the electrostatic force experienced by the charge. Q is the magnitude of the test charge. Now, move on to second question. A circle of radius r is drawn with charge jour q at the center. The work done in moving a point charge once around the circumference of the circle is. Answer is 0. The work done in moving a test charge from an initial point A to a final point B is equal to the charge multiplied by the difference in electric potential between the 2 points. Since all the points are equal distance from the charge at center, potentials will be same and there is no potential difference. Hence, work done will be 0. Next is question 3. Which of the following gives the polarity of the induced EMF? Options are A. Biot-Savart law, B. Lenz's law, C. Ampere's circuital law, D. Fleming's right-hand rule. Answer is option B. Lenz's law. This is picture of that great scientist, Heinrich Friedrich Emil Lenz. Lenz's law states that the direction of the induced current, and thus the polarity of the induced EMF, in a circuit is such that it opposes the change in magnetic flux that produced it. This law directly addresses the polarity of the induced EMF. In the fourth question, frequencies of radiations in M spectrum. Question is, the frequencies of gamma rays, ultraviolet rays, and X-rays are F1, F2, and F3 respectively. Then, A. F1 equals F2 equals F3, B. F1 greater than F3 greater than F2, C. F1 greater than F2 greater than F3, D. F3 greater than F2 greater than F1. Answer is B. F greater than F greater than F. Picture shows the complete electromagnetic spectrum radiation emitted from Sun. As we can see, gamma rays are of highest frequency and of lowest wavelength. Then comes X-rays and then ultraviolet. Now, moving on to fifth question. If the radius of the first electron orbit of hydrogen is r0, the radius of the second electron orbit of hydrogen is. Answer is 4r0. According to Bohr, the radius of the yth orbit is Rn equals n square r0, where r0 is the Bohr radius of the first orbit, n equals 1. For the first orbit, n equals 1, r1 equals 1 square r0 equals r0. For the second orbit, n equals 2, r2 equals 2 square r0 equals 4r0. So, the radius of the second orbit of hydrogen is 4r0. Question 6 is, two thin lenses of power jour 4D and -2D are in contact. The focal length of the combination is. Answer is 50 cm. Let me explain how we get 50 cm as focal length for the combination. The lens having positive power is convex and negative power is concave. When we keep these lenses in contact, effective power will be the sum powers of two lenses, considering the sign. Hence, effective power is jour 4 diopter minus 2 diopter equals jour 2 diopter. Then focal length of the combination will be reciprocal of effective power. That is, 50 cm. Last question in this video, question 7. Which process is responsible for the production of energy in the Sun? Nuclear fission, nuclear fusion. Answer is nuclear fusion. Nuclear fusion is the process in which two light atomic nuclei combine, fuse to form a heavier nucleus, releasing a huge amount of energy. It is the process that powers the sun and other stars. Nuclear fission is the process in which a heavy nucleus splits into two or more lighter nuclei, along with the release of a large amount of energy. This usually happens when the heavy nucleus is bombarded with a slow neutron. Thanks for watching. For more videos, subscribe to our channel. Physics Time.